Welcome and hello. This is a video lesson in the HEC RAS controller. We're going to be talking about exporting results to a CSV file. So what you see on the screen here is my completed HEC RAS model. We're going to run the computation and then export the results to a CSV file. I'm going to show you how that's done using the HEC RAS controller. All right, so let's go ahead and get started. To run your model, this is an unsteady flow model in 1D. I'm going to go up to run and then unsteady flow analysis. One thing that we need to do to allow this to work for the HEC RAS controller is we want a .hyd file to be created in our project directory. That is a file that the output underscore computation level underscore export subroutine is going to be using for the creation of the .csv file. So just trust me when I say you're going to want to go up to options and then output options. Okay, in this dialog box, click on computation level output options and then check this checkbox right here for write computation level output file. So at the moment, I haven't ran the simulation yet with this checkbox checked, which is why right here in my project directory, I do not have a .hyd file. It'll be .hyd number associated with the plan, I believe. So we're going to come back to the project directory here after I run the computation and just confirm that that file was created, and then we'll get to the HEC RAS controller code. All right, a couple of other things to mention in this dialog box. If you wanted to limit the start and end date time of the results that are written to the .hyd file, this is where you can do that. If entire simulation use unless specified, so I'm just going to leave that blank. Also, I've got additional variables right here, which I could write for viewing results as well. So, I'm just going to go ahead and check them all on so that we can see these results if we need to, and then click OK. So this little note down here popped on screen, computation level output is on. That is good. So I'm going to just save the plan one more time. I should also point out that the computation interval, this is one of the computation time settings, is set to 1 minute. So this is the interval that the .csv file is going to be exporting the results to. So the smaller this time interval and the longer the simulation, the start and end date time, the more data you're going to have in that .csv file. There is a warning when running the HEC RAS controller script that this routine could take a while if you happen to have a very long simulation and short computation time interval. Okay, so that's done. I'm going to click on compute. Let's wait for this to complete. Okay, that's done. So just 6 seconds. Let's click on close. First thing I want to do is click on the project directory. I'm going to go right click, show more options, and refresh. And up here it is right here, project.hyd01. So that was the file that was just created. It looks like it's less than 1 megabyte, so that's a rather small file. Question is, how large is our .csv file going to be? And we'll find out in just a moment. So I'm going to minimize that. Let's go over to Excel. I have an Excel file here already prepared in its own worksheet. It's called controller.xlsm, so make sure to save your Excel file in a macro-friendly format, which you can do by going up to File, Save As. Make sure you're selected Excel macro-enabled workbook.xlsm. Okay, I've already done that. Let's head over to the Developer tab and then click on Visual Basic. Here is my place to input the HEC RAS controller code. I'm going to do that. I have it prepared ahead of time. So here is the export data subroutine. I'm just going to run it directly right here in the IDE. I'm not going to create an interface or create a button or anything like that. So the first thing we're doing is creating a HEC RAS controller object, and it is going to open our project, which is our project.prj. After that, it's we're going to prepare the parameters, and then using those parameters and this output underscore computation level underscore export subroutine, here are the parameters we're going to pass it. That is going to write the CSV file. The first parameter here is the path to the .csv file, so I'm just going to call it results.csv. And then this is the absolute file path with a little bit of a shorthand here, so it's referencing the file path of the Excel file, and then it's going up a directory into the projects directory, into the HEC RAS directory, and then that's where I want my results.csv file to be created and saved. After that, we have an error message string that's blank and passed in. That's potentially returned if there is an error. In fact, I'm going off script here, but what I want to do is actually export that error to the intermediate window in the off chance that there is an error. So I'll just call this print error and then debug.print. This is going to be error equals ampersand error message. Okay, actually, the label should also probably be error message, and that looks good. Never can be too safe. All right, that is the end of the subroutine. We're going to also close HEC-RAS, so I'm going to need to remember to close it first before running this, but let's go ahead and save. Like I said, I'm going to go to HEC-RAS. Let's save that, close HEC-RAS. I'm going to also open up the intermediate window, so view and intermediate window. Here's that. Export data. All right, run and run the subroutine. Okay. So it looks like it ran. Error message is blank, so I assume that's no errors. So I'll close that up. Let's go ahead and check to see if we have a CSV file and also how large it is. So let me go ahead and right click again, refresh. Okay. At the top here, we have the results.csv file. Again, less than a meg. It was about the same size as that .hyd file. Let's go ahead and just take a peek at it. So this is me opening it up in the text editor. Edit with Notepad++. And here it is. This is what I have. So definitely a .csv file. And then at the top, we have the column headers. So we have river, reach, river station, flow rate, the stage, the area, and the top width. And then we have the date time of the simulation. So this simulation starts on January 1, 2020 at midnight. So the very beginning of the year, 2020. However, what we're seeing here is the first minute of the previous hour, the final hour of the year 2019. And I believe that's the case because I have a 1 hour warm up period as part of this unsteady flow simulation. I didn't mention that before. I didn't show you that on the screen, but I strongly suspect that that's what's happening there. So as for the actual data, here's our river, here's our reach. Here is the river station. So 1,000, 960, 900, 800, 700, and down to 0. Comma, and then after river station is flow. So it starts at 10,000 and then 10,000 and then 10,002, 10,004. Very little variation right here. It looks like it does drop quite a bit after the bridge. So anyway, I'm not really focusing on that level of analysis. And then we have a comma, and then we have the stage. So 516 is the stage. I'm not seeing the area, and I'm not seeing the top width, and I had that same problem when preparing for this video. I wanted to make the video anyway, but I'm just being honest, I don't know where the area or the top width were written to in this .csv file. Clearly, there was something's wrong with that, and it could just be my geometry, but if someone has that figured out, go ahead and leave a comment, let me know, and then I can investigate. But yeah, anyway, we've got the flow rate, we've got the stage, and we've got that for all of our cross sections for our river reach, for all of our profiles, which is every single minute of this 24-hour period, or rather 25-hour period, if you count the 1 hour warm-up time period, because here we have the next minute, and then the next minute, and then that just continues all the way down for thousands of lines. It looks like we're about 21,000 lines here. But again, the file is less than a megabyte, so it's not large at all. Okay, you know what I want to do now is demonstrate how to bring that into Excel. And of course, there's lots of different ways, but the way Excel probably expects you to do it is to click on Data, and then click on Get Data, and then from File, and then from Text/CSV. After that, it's expecting you to navigate to that file and select it. And I've already done this, so I just happen to be in the correct directory. Here it is, results.csv. So I'll click on that. All right, so it's giving me a little bit of a preview. Correctly guess that I want comma separated delimitation. And yeah, let's go with that. So I'll click on the load button down in the bottom right. And then boom, here is my data. Yeah, as I suspected, we're not seeing any area or top width, but what we have is pretty good. We have the flow rate and the stage. This is just for the very first minute of the warm-up period. And then further down, we'd have data for, what is this? 12:30 p.m. So this is about halfway through the simulation. The flow rate's still 1,000. Let me go back to a different flow rate here. All right, here we go. Flow rate is 35,000. and it looks like it decreases further down due to flow out of the river through the lateral structure, and perhaps the bridge has some sort of contribution to that. Here is the stage data, and again, we're missing the area and top width. So at this point, we could post-process this data however we want. We could write a script. We could actually modify the import procedure. We don't have to bring it in using the data menu tool here. We could write something in Visual Basic or Python to manipulate that .csv file so that the imported data is just as we want it. I should probably also mention another easy way to export this kind of data is in the DSS file, of course. There's time series data set for the stage and for the flow. So that just loaded up here. If you scroll down to the bottom, we have path for flow, we have path for stage. Oops, not that stage, this stage right here. And then beyond that, there's also in HEC RAS a menu item for, let's see, I need to open up my HEC RAS again. Okay, I've got HEC RAS open. If you go up to View and then Unsteady Flow, Time Series Plot, Computation Interval, and then let's see here. So the variable we're currently looking at is the water surface elevation. We can click on Variables and toggle that on. We can look at the flow rate. We can look at any of these values that we checked on in the checkbox. So depth, for instance, we check that one on. With those three variables in our plot, I can click on the table tab, and then I can just very quickly and easily Control C, highlight them all, Control C, go back to Excel. Let me just get a different worksheet here. I can paste this data in just the same. And now we have our, what is this? The stage, the flow rate, and the depth for every single minute of the simulation for 24 hours or 25. Yeah, it'd be 25 hours because 25 times 60 is 1500. So it's 25 hours worth of data right there. So that's another option. And then the last option, you probably saw it, instead of a time series, this is a spatial plot. So this is the same variable right here over the entire reach. So 1000 river station down to 0 river station. We could toggle on different variables, and then we can select the profile too. So this is just one profile. And if you wanted to export that data, you can click on the table tab. Here's that data. Again, Control C, Control V to export is a quick way to get that data. But I'm going a little off topic here. This video is about exporting the results to a CSV file, and we did that using the HEC RAS controller and this output computation level export subroutine.